Second half of tonight's video is about weight. So the weight, or FG, as we'll use in my class, there are a lot of different notations for this, by the way. Sometimes weight is labeled W, sometimes it's simply labeled F. However, the AP exam uses W and F for other things, and so in my class we will call weight F subscript G. Anyway, definition, which you should definitely know. The weight, Fg, of an object on Earth's surface is the gravitational force exerted on it by the Earth. So, everything that has mass causes gravity. And Earth has a lot of mass. So if you've got something near Earth's surface, the Earth pulls down on that thing with gravity. So the force of the Earth pulling down on that thing is Fg, force of gravity. So at this point you might be wondering, what's the difference between mass and weight? Well, in this equation that we're going to be using in tonight's video, weight Fg and mass m are clearly different things. So let's talk about what they are. Mass is how much stuff something has in it. It's not dependent on where the thing is, it's just how much stuff something has in it. Or how much matter. But stuff is actually a good word. How much matter or stuff something has in it. Weight is how much gravity pulls on an object. Sorry. Object. Weight is how much gravity pulls on an object. And these two things are related. The more mass something has, the more weight it has whenever there's gravity. But if there's no gravity, so let's assume that gravity goes away, if we get rid of gravity, there is still mass, because gravity does not affect how much something has in it. But if we get rid of gravity, there's no longer weight. Weight requires there to be gravity. Okay, so let's take these concepts and try some problems. We can use the fact that Earth causes all objects to accelerate downward at 9.81 meters per second squared to answer several questions about things that happen on the surface of the Earth. So I'm going to work through these three examples with a pretty simple equation and talk about what exactly it means in each one. So example 1. What is the weight of a 5 kilogram apple on Earth? Okay, to calculate something's weight, we're going to use the equation Fg equals mass times the acceleration of gravity. So weight is the object's mass times g. And remember that g is 9.81 meters per second squared. Okay, so now that we know that, let's try something else. What is the weight of a 5 kilogram apple on Earth? Now this part here where it says on Earth is actually important. You might think, oh, well, everything happens on Earth. Not necessarily. This equation for weight right here, using this number for g, applies only on Earth. And I'll do an example later where it's on Earth. So, I am finding the weight of something. Therefore, I know I will use Fg, weight equals mass times gravity. Remember, Fg is the weight. This is the weight of a 5 kilogram apple. This equation is already solved for Fg, so I can just plug in. Fg equals 5 kilograms. Oh, by the way, I did a bad thing here. So I've been trying to impress on you that you should write down your givens. Here are my givens. 5 kilograms as my mass, and we've already written down G. For convenience, I can always say G is about 10 meters per second squared. Makes things a lot easier. However, I do have to declare that I'm using that. In the AP exam, you would have to write, if you were using 10, G is about 10 meters per second squared. And I'm going to pause and point out something. These units are going to get confusing. Meters per second squared and kilograms, that doesn't quite work out. So what we're going to do often in my class, and I'm going to push you on this because it really conveys an understanding of what gravity is, whenever we're solving weight problems, we're going to relabel acceleration of gravity as 9.81 newtons per kilogram. Now, newtons per kilogram are in fact the same thing as meters per second squared. And I will explain that to you more as we move through courses. Right now the explanation would not make a lot of sense. And I'm trying to make videos short, so I don't want to go too into depth. But we're going to say, whenever we're solving weight problems, that G is 9.81 newtons per kilogram, or about 10 newtons per kilogram. So now, the problem will make more sense. Fg equals 5.0 kilograms times 10 newtons per kilogram. Kilograms cancel. 50 newtons. And in physics, newtons are the units of force. N equals newtons, which are the units for force, named after Isaac Newton, who discovered the force of gravity on Earth. Okay, second example. What is the mass of a person that has a weight of 600 newtons on Earth? For these problems, I will say gravity is about 10 newtons per kilogram. And by the way, so this symbol here, the equal sign with the squiggly, means is about. This symbol here, two squigglies, also means is about. Just in case you were wondering why I switched them, they're interchangeable. Okay, so I know I'm using weight equals mass times gravity because I've been asked a question about weight. And I want to know the mass of a person who has a specific weight, so I need to solve this equation for mass. So what I'll do is I'll divide by g on both sides. And remember, this little g is a subscript, and so it doesn't go away. It's actually part of the f. It's not a separate variable. It's a subscript. So now I have fg over g is mass. And from the problem, I had a weight of 650 newtons. So now I can sub in 650 newtons, 10 newtons per kilogram, and I get 65 kilograms. I'm going to check my units there. Newtons over kilograms. In the bottom of a fraction, the units flip, and so kilograms end up on top. But I have 65 kilograms. Okay, so new problem. What is the weight of a 12 kilogram ape on the moon, where the acceleration of gravity is 1.63 meters per second squared? Okay, so we have a little problem. Remember I told you this information works only on Earth, and now we're on the moon. So we cannot use this acceleration due to gravity. We have to use the one on the moon. And let's see what the problem says, where the acceleration of gravity is 1.63 meters per second squared. So gravity on the moon is 1.63 meters per second squared, or, remember I told you newtons per kilogram are the same thing as meters per second squared, 1.63 newtons per kilogram. Now I can solve the problem. The problem asks us for weight, and it gives us a mass of 12 kilograms. Weight is mass times gravity. Mass is 12 kilograms. Gravity on the moon is 1.63 newtons per kilogram. Kilograms cancel. We get 19.56 newtons. That is the weight of an ape on the moon.